Okay, so hi guys. So today I will be discussing the design of compression members. So let's start. First of all, let's look at this here. So the approach to the design of the member is subjected to combined axial force and bending in accordance with the strength design method of the ACI code may be divided into three categories. Okay. So we have in here design for region 1 right here. Designed for region 1 for a member having small or negligible bending moment. For example, yung maximum permitted axial strength na PN maximum governs. Then we have designed for region 2 which in which a section is compression controlled pero yung strength PN is less than the maximum permitted strength of 0.80 PO for tight columns and 0.85 PO for spirally reinforced columns. And lastly, we have designed for region 3 in which the eccentricity is greater than the balance eccentricity and or yung kanyang tensile strain is greater than the yield strain. Okay, so although designs in region 1 is permitted by the code, okay, this design is nevertheless discouraged. Okay, since a member is subjected to compressive forces close to their pure actual load capacity possess a low deformation capacity and thus may fail without warning. So let's start first with region 1. This is purely actually loaded beams. So madali lang naman ito. So kung babalikan nyo yung previous module ninyo, nakalagay naman doon kung ano yung mga gagamitin na formula. Okay? So in here, nakalagay dito, yung maximum PN natin should be 0.80 of PO and 0.85 na PO if spirally reinforced. So it really depends. So for now, let's take a look at our problem number 1. Okay, so problem number 1 natin. Oh, by the way, I will just be focusing on two regions lang muna, region 1 and region 2. Kasi yung region 3, we don't really want our columns kasi to be on the transition zone or tension controlled sections. So I will just be focusing on region 1 and region 2 since we want yung ating columns to be compression controlled or purely axial. Again, yung region 1 is highly discouraged, but we will be discussing it uh, in this topic. Okay, so let's start with problem number 1. We need to design an actually loaded spirally reinforced circular column for a gravity dead load of 345 kips and a live load of 405 kips using approximately 3.5 longitudinal reinforcement ratio. So the column is of average height and it will be assumed slenderness effects can be neglected. Use F prime C 4000 psi, Fy is 60,000 psi, and then we use the ACI code. By the way, the approach of the ACI code is just similar to the approach of your NSCP. Okay? So first of all, in the design, of course, dito ko na lang siya ilalagay. First step is to actually write the given. Okay, so mga given tayo. First one, meron tayong binigay na dead load, which is equal to 345 kips. And live load natin is equal to 405 kips. Okay, and then we use now a longitudinal reinforcement ratio rho equal to 3.5%. Okay, so wala namang slenderness noon na stipulated in the problem. So, lagay na lang din natin yung value ng F prime C and Fy. So, 4,000 PSI yung F prime C and 60,000 PSI yung ating Fy. Okay, so the first step is to actually determine, okay, so let's proceed with the solution. Okay, So step 1, of course, since this is the sign, we have to identify muna yung nominal strength Pn. Okay, so we have to determine your Pn. Okay, so kailangan natin i-factor since the given loads are actually service loads. Okay, so kailangan natin gamitan ng factors. So your Q is equal to 1.2 ng dead load plus 1.6 ng live load. So your PU now is equal to 1.2 of your dead load, which is 345, plus 1.6 ng live load mo, which is 405. Okay? So your PU now is equal to 1062 kips without your PN. Okay? Your PN will be equal to 1062 over your reduction factor 0.75. So refer to your previous copies na lang. Okay, so let me just calculate that. 0.75. That is 1416 kips. So yan yung magiging nominal strength mo. So this should be the nominal strength of your column. Next, we proceed with the column size. Okay, pwede na tayo mag-design since meron na tayong nominal strength. Okay, according to the code, your PN maximum, okay, for tied columns, or should I say for your spiral reinforced column, should be equal to 0.85 ng inyong PO. Okay? So, substitute na lang natin. Refer to your module 8, I think. Your module 8, nandoon yung formula ng inyong PO. So, 0.85 Ag. Since this is purely actual because it's under region 1, 0.85 ng F prime C times or plus your log G times Fy minus 0.85 ng F prime C. Okay, so this will be your working formula. Okay, so yung PN max natin kanina is 1416. Your PN max is 1416 must be equal to 0.85 gross or area ng concrete times 0.85 times 4K, okay, plus 0.035 okay, times 60 minus 0.85, or should I change this one to a bit? So 0.035 times 60 minus 0.85 times 4. Okay, so yan yung magiging working equation natin. So calculating your AG now is equal to, just calculate this, 416 0.85 times x times 0.035 times 16 minus 0.85 times 4. So your AG will be equal to 309.59 or inches square, or approximately AG now is equal to 310.00 inches square. So, i-round up ko na lang yung value ng AG natin. Okay, so what will now be the diameter? Since this is a spiral column, we have to calculate for the diameter. So AG is equal to pi over 4 d squared. So 310 equal to pi over 4 d squared. So your diameter now is 19.87 inches. Okay, so 19.87 inches yung magiging diameter ng column mo. But if I were you, I would make this approximately, syempre kung mas laki yung size, mas maganda. Okay? I would say that this is 20 inches. Okay, so of course we made some a few modifications, so that's why we have to modify ulit yung ating area. Okay, so what will be now the AG of the new beam? So your AG now is equal to your AG is equal to 314 or 100 pi inch squared. So that will be the new gross area of the concrete. Of course, we made some modifications. We have to identify now the area of the longitudinal steel needed by the column. Okay, so yun pa lang yung column size. So we made some modifications, and now we can calculate for the area of the steel required. So since nag-modify tayo, we need a new value of your ratio, your column reinforcement ratio. Okay. Dito ko naman ilalagay. Okay, so reinforcement. So for reinforcement, kailangan natin i-calculate ulit yung magiging needed yung ating rho G. Okay, so we still have 1416 as our nominal strength. So times 0.85. Ulitin lang natin ulit yung nasa step number 2. Okay, and then ang gagamitin naman natin is yung bago ng area. Okay, or rather, this is 100 pi times 0.85 4 plus your rho G times 60 minus 0.85 4. Okay. So calculating this, mo pa naman yung rho G mo. That is 85 times 100 pi. So your rho G is 0.0336. Okay, it's 336. So ano kayo na magiging required na area ng steel reinforcement ninyo? Okay, so tandaan na rho G is equal to your AST, or the area of steel reinforcement, divided by your gross area. Okay. So this is now 0.0336 is equal to ST over 100 pi. So your AST now is 0.33 0.0336 times 100 pi is 10.56 or 10.56 pi, or rather 10.56 inches squared. Okay? So yung area ng steel na kailangan natin as reinforcement, this is our longitudinal reinforcement parang ha, is 10.56 inches squared. Okay, so for an area gross of 100 pi inches squared, required na area is 10.56 inches squared. Okay, so yun yun. Now, if we will try to use number 11 bars, ilan kaya yun? So, let's try to use number 11 bars. Try lang naman. So, you can definitely use any bar that you want. But for me, I'm gonna use number 11 bars kasi medyo malaki yung area ng concrete. So, how many? Okay, so your number of bars needed is 10.56 inches squared divided by anong area ng isang bar? Number 7. Okay. Let me just look kung anong magiging area ng number 7 bar. Okay, wait lang guys. Bear with me. Kasi hindi ko memorize yung area. Let's see. For number 7, ang area ng number 7 is 0.60 inches. Number 11 rather. That is 1.56. Okay, so the number of bars needed is 6.76 or approximately 7 number 11 bars. Okay, so this is the number of the bars that you're going to use. Okay, so sir, tapos na po ba tayo sa problem? Hindi pa po. Of course, we have to design for the spiral reinforcement or yung transverse reinforcement. Yeah. Okay, so I'm gonna continue. So this is for the transverse reinforcement, not for the longitudinal reinforcement. Okay, if you're going to check your tawag dito, if you're going to check your module 8, nandun yung spiral reinforcement formula natin. So yung spiral formula for transverse reinforcement is 0.45 times your AG over area times the core times F prime C over F1. So ito yung magiging formula ng spiral reinforcement. So I'm gonna be using 1.5 inches na clear cover. I'm gonna use 1.5 inch na clear cover. So yung area ng core ko ngayon is equal to pi times 20 minus 3 squared over 4, and this is approximately equal to, wait, so I'm gonna do an AFNR again. Pi times 20 minus 3 squared over 4 and that is approximately equal to 2 to 6.98. Kung sabihin na lang natin, that is 2 to 7 inches squared. Okay, so next thing that you're going to do is to actually calculate now your S from the equation kanina. That is 0.45 times 314 ito 100 pi yun. AG natin kanina is 310. Okay. 100 pi. 100 pi. Okay, 100 pi over 2 to 7 minus 1. Okay, times 4 over 60. So your raw S now is equal to, calculate ko lang yan, 45 times 100. Raw S is now equal to 0.0115. Okay, so we can now determine your maximum spacing. This max is equal to 4 ASP. Module 8 po ito. Tignan mo lang. Times raw S times DC. And this is now equal to 4 ASP over 0.0115 times diameter ng, that is 17. Okay, so your DC is 17. It's the diameter of the core itself. So, kunin nyo na lang yun. Dito mismo, 20 minus 3. Dito yun, guys. Nakuha sa 20 minus 3, diameter ng core natin. So, yung sa core natin, ito yan. So, ito yung pinukuha nating area. So, what will be this diameter? Okay, from the outer perimeter of the transverse reinforcement. So, that's why 17. Yun. So, assuming that we're going to use number 3 bars for the spiral reinforcement, okay, so assuming we use number 3 transverse reinforcement, okay, so ang mangyayari is ang S-max mo na ngayon is equal to 4 times anong area ng number 3. Okay, the area of number 3 is 0.11 over 0.0115 times 17. So what will be your maximum spacing? Okay, so our maximum spacing natin is 2.25 inches. Okay, so this will be your maximum spacing. Or I can just say na yung spacing natin is approximately equal to 2 inches. Okay? So this is the spiral reinforcement. Okay, so ibig sabihin, ito from there, that is 2 inches. Okay? So kunyari, ito yung core, just nakapuligot ng ganyan, yung core natin should have a 2 inches na spacing. Okay, so that's all for number 1. Okay, so again, it is when it comes to design, first thing that you're going to do is to calculate the nominal capacity given the amount of load from the problem, and then determine the column size, okay, using the maximum nominal capacity for actually loaded beam. Okay, that's 0.85 PO for the spirally reinforced column and 0.80 naman for tight columns. So, ito purely actual, purely based sa formula yung kanyang concept. So, you have to apply this, makuha mo. Okay, ako naglagay ako ng konting modification kasi in-increase ko yung size ha. That's why, kinapit ko ulit yung AG, okay, as well as yung raw G. Okay, kasi bida-bida ako eh. So, after mo makuha yung raw G, you can now calculate the reinforcement. Okay, so yung AST dito, yun yung hinahanap natin, reinforcement. That is longitudinal reinforcement. So, ano yun? Yung longitudinal na sinasabi ko is, kunyari ganyan, ito, yung mga yan. These are the longitudinal reinforcements. Yan yung mga yon. Okay, so that is your AST. Okay, so nakuha natin AST is 10.56, and then I just assume na I'm gonna be using 11 bars. So ang nangyari is that N equals 10.56, which is yung nakuha natin AST divided by yung area ng isang number 11 bar. So approximately, we can use 7 bars. So kayo na bahala kung paano i-layout yon. So, kung 7 bars, probably 1, 2, 3, 4, 5, 6, 7. Ganun. Charot lang, hindi pwede yun. Okay. So, kayo na bahala guys kung paano nyo i-ganun yun. Problemahin ko pa. Okay. Siguro ganito. O ganyan. 1, 2, 3, 4, 5, 6, 7. Ayan. Basta, yan. Ganun. Okay, and then after the reinforcement, we now proceed with the calculation of the spiral reinforcement. The spiral reinforcement, as I mentioned, yung nakapulipot na ganyan. Okay, so we need to calculate the spiral reinforcement spacing. Okay, so ganito yung process. This is given dun sa module 8 formula. And then we have the area of the concrete, of the core of the section. It's your ACH, and then pwede mo na makuha yung SMAX. So, ang importante dito is ito and then itong formula na ito. Okay? So, in here, ang assumption ko, I use number 3 bars for the spirals. Okay? So, huwag kayong magtaka kung 0.11 yung nagamit kasi that's for number 3 bars. You can definitely use a larger or smaller, bahala ka. Okay? So, that's for problem number 1.